and our today's faculty, Sri Naveen Sharma ji. Naveen Sharma ji is Manager Traffic and Transport Expert in KPMG India. All of you know that we are conducting online mode of the training program on intelligent transportation system applications for highway from yesterday, that is on 26th of September. Today is the second day of this training program. Yesterday, we have covered ITS in traffic management and highway and its real-time application. And today, we will discuss on intelligent transportation systems, in that its overview and usage in highway and enforcement solutions. So I will request to the participant that please ask the questions from our faculty, sir. And our faculties are try to give the answer of all of your questions, or try to make it a interactive session. But for a interactive session, participant should also be interact with our faculty. Today also there will be a 15 minutes time break at around 11:15 to 11:30 during the presentation, as well as at the end of the presentation also. Participant can also ask their questions and raise their query, and our faculties will try to give the answer of all of your questions. So I will not take much more time. I request uh, Sri Naveen Sharma ji to start his presentation and experience with the participants. Thanking you.
Thank you so much, sir. Hi, good morning, everyone, to all the participant, and hope it will be a good morning to all of you. What we'll try to do in this session is we'll try to be interactive. If anyone have question in between, they can definitely raise it, or we can have question and answer round in the end of maybe the 15-minute break time or towards the end of the session. So the topic which I am covering, I hope I am audible to each and everyone, and the screen is visible.
Yes, sir. Yes, sir.
Okay, great, great. Good to know that. Okay, so the topic which given to me for sharing my experience as well, some of the use cases which is there in India and around the world, is related to intelligent transportation system, and basically its uses in highway operations as well as urban roads in India. So I guess my background is been told by sir. So I'm a traffic and transport planning expert. So done my graduation in civil engineering and then done my master's in transport planning from School of Planning and Architecture. After that, from last 10 and a half year, I am working in transport sector, worked in core of the sector, and then now in working in KPMG with the smart city solutions. So when we start with I'll just cover what the definitions means. I hope everybody will be knowing in this sector who are the participants. This is very well known to you what intelligent transportation system means. And what it does is, so it basically applies those advanced technology to make the transportation system more efficient, more safe, and more service friendly, so that it gives you a high potential revenues as well as given advantage to the stakeholders to utilize it. So, so what does it mean is utilizing those electronics, communication, computer control, and detecting system to help make transportation system safer, efficient, and service and traffic situation friendly. And this is all being done in a real-time manner so that those information can be utilized in an efficient manner. For example, I'll just take an example. For let's say there is an highway, and we know that there is a capacity which has been reached by the highway, and we don't have an option in going for another route or another highway to make in the region. Now, how ITS can help not increasing the capacity, I will say utilizing its capacity to its fullest volume. So we can have those computer-based, electronic-based solutions which can help them in utilizing and planning of those commuter which are plying on highways to full of its advantage value to its capacity value. So that is the advantage which comes with the help of ITS, and it implies making the transportation system safer, efficient, and service friendly. So these are the some of the application area, if we look at it from the perspective of traffic enforcement, traffic management and monitoring of roadway system and traffic junctions. Interface it with the transit operation when we talk about the bus operation, metros, or intermediate public transport operation. It also helps in those transit management and operation as well. Then it also provides an interface to different agencies which are working simultaneously with the implementation agency as well. And it also provides a way to disseminate the information to its user. So these are the different application area on which ITS has been utilized. I won't go into detail of each and every one, but this is the overall application area which ITS can cover. So how I've outlined this presentation is, so we will define certain details related to why there is a need of traffic solution, why ITS is important. Then what can be different possible solution and what is being utilized in India right now, and then some of the use cases. And what do we mean broadly in terms of intelligent transportation system in highways and its utilization for highway and expressways in India. So when we say why there is a need, so so the numbers are very correct. If you look at various numbers, there is a robust demand. These numbers are old, but it still gives you a value of why we require this and why we have advantage of having this infrastructure planned at the execution time itself. So it should not happen that we have planned an highway and then 10 years, 12 years down the line, we are thinking of now we require an intelligent traffic management system to make this highway management and operation smooth and safer for the users. So this should not happen. The cost of this intelligent traffic management system or making it a management friendly system, it should be inbuilt into the project itself. So numbers are there. So in terms of total expenditure in 2019, I hope my screen is visible.
No, sir.
Okay, let me share again. Is it visible now?
Yes, sir. Yes, sir. Yes, sir.
Okay. Probably somebody have shared his screen. No issues. Okay. Then, so these are the number. These are the old number. If you see, 83,000 crore of investment is been planned and estimated for total expenditure in 1920. Then the growth estimates are moving at a percentage of 5.87 of CAGR value. Then there are opportunity. We are building new highways, expressways around the corner. And there is a policy support also. So there are different national investment fund, infrastructure fund is been created all around the country, which are helping and supporting those planned infrastructure and planned highways around the corner in India. And every funding agency are right now at the corner asking country to take the funds and invest in infrastructure so that will help in generating more revenues towards their end. Then when we see the market size and key trends, it clearly tells us that the value has been increasing day by day. And these numbers are taken up to December 2018, and these are the estimated number, which shows us a overall percentage CAGR improvement of 23.25%. Similarly, with number of the value of amount which has been budgeted under the union budgets is increasing many folds from year to year basis. So now, so in overall, what we see is what ITS adds the value is that they decrease down that human interface into the operation and management of a system. So if in terms of congestion on the road, we look at it, it gives a picture of how much wastage, how much longer time we are spending on the roads, which can be utilized for productive advantage for a person. In terms of fuel wastage, this is just an example that so for Delhi, it loses about 11.5 crores per day in terms of fuel wastage every day. And these numbers are increasing day by day. Are making more highways, more underpass, or more roads is a solution? Yes, it can be one of the solution, but it is not a full solution which needs to be provided right now. In terms of number of liters of fuel wastage per day, it leads to a number of 30 lakh per liter. I'm just talking about one city. And if you calculate over a country, you will get the numbers that it is very, very, very unproductive, which we are losing in terms of fuel wastage every day. Then the time we spent on road is also been increasing day by day. This is just an example that Los Angeles, they lose about 56 hours a year in travel times. Whereas this time can be utilized in terms of spending happy time with our family, productive time in doing something else. So those things needs to be catered in when we're planning for a transportation system or a highway for a city or overall intermodal connectivity.
रिया कुछ
So now, in terms of what it does is
बाहर देखो
it
कोई आया क्या?
reduces. Somebody is saying something.
No, sir. Continue, sir.
Okay. So what it does is it overall reduces the overall efficiency of road transportation system. Now, this is just an video. Let me know if this sound is everybody can hear the sound and see the video.
It's not audible.
It is not audible.
No,
No.
sir.
Okay. But the video is visible, right?
Yes, sir.
Okay. So it talks about that 5 major cities of India and how much travel time has been occurred every day in the city, which gives you an example that how much one person is spending overall in time duration on the roads. From our office to our work location. So this should not happen ideally. But so the existing infrastructure is having a particular capacity. And we don't know how much demand is being generated and how much demand it needs to be catered through the infrastructure till now. But when we start utilizing those intelligent traffic management system, we very well get that what is my current demand of existing infrastructure is number one. Number two, how much I require to add on the capacity. Above that, point number three, it utilizes the existing space which is available to its complete capacity value. So that numbers will give me actually what I need to plan for next 50 years, which were used to also used to do it before as well, but those are based on certain models, probability model, which have its own limitation. So this gives an overall picture of real-time basis, and its advantage can also be seen in a lot of projects which has been uh, under implementation stage or implemented inside or outside India. So this is a report which has been generated every year by Numero. So this gives an overall value of what is the traffic congestion level in different cities around the world. So if you see this image, it talks about the traffic density from lowest to highest, green and red to the highest. And you can see there are 5 major cities of India which are under red right now as compared to the other part of other world. If you see the numbers, these are the top 6 cities in which 3 of the cities are. This starts from Delhi, Kolkata, Mumbai. It talks about traffic index, traffic volume, what is the inefficiency index, and what is the CO2 emission level right now. Inefficiency index is the value which has been calculated based on the how much ideal time you are spending on the road. So if you can see, the situation is very critical and it is been increasing day by day. So ITS can be a solution which can help mitigate those problems. I'll not say it will provide a complete solution, but it will definitely give us some relief in terms of decreasing the congestion level in the cities. Now, in terms of congestion, we very well know it increases our travel time. It increases our travel cost. It adds to the air pollution level and also creates an accident risk on the highways and roadway which the stakeholders are using. Now, what are the options we have? Option one, I guess many of the agencies and implementation agency which are working on the ground are utilizing it. Construct a new roads. It can be one of the option, but it is not the overall option which we have right now. And right now we are a developing country and we are doing it at a large stage, but there will be a stage will come on which we will not be able to do at a large scale because we have to invest so much into the operation and maintenance of those highways which we have created. So that opportunity cost needs to be built in when we are thinking of constructing a new road every time. Then reducing the traffic. So overall travel demand management and alternative solution can be an option which can help increase the capacity of existing infrastructure. Not only highways, I'm talking about the overall transportation system. It includes metro, includes light rail transit, it includes intermediate public transportation system of the city. So all those modes can be clubbed together, can be interact together utilizing the intelligent traffic management system and can have a positive impact in terms of reducing the congestion on the road. And then ultimately, so it should be a club of all three solutions, constructing new roads, reducing the traffic, as well as increasing the existing infrastructure capacity with the use of intelligent transportation system. This is just a pictorial view. Construction is a part of solution, but how? So if you see, the value lies from 2 to 12 crore per lane kilometer to be built. These are some of the example which has been taken up from the research. Alternative solutions, alternate mode of transportation, we are still utilizing it, like Hyperloop, SkyTrain, all those part of solutions help in mitigating the existing traffic condition or traffic congestion on the road. Then ultimately the increase in traffic. So there's a small video. This is for Mumbai Airport. Let me just give you a brief summary about this video. So this is about the Mumbai Airport and how the intelligent transportation system in this case is helping utilizing the existing capacity of an highway. So Mumbai doesn't have, I'll say, parallel highway because there is a limitation of space. Okay, it is what it offers to the operating agency is a crisscross uh, uh, landing surface. So at the same time, when we don't have the uh, parallel landing tracks on the airport, it's still with the help of intelligent transportation management system, it helps in increasing its capacity, utilizing its capacity to the fullest volume. Let me know if the sound is everybody can hear the sound. Otherwise, I'll play in video mode. Is the video is not
तो दोबारा करते हैं ना, काट के तो फिर आवाज आने लग जाती है.
okay? So let me play in a video mode. Probably that will be here.
करना पड़ता है. पापा है ना, वो आगे पापा ब्रांड नहीं खाते है ना.
You can hear now.
Yes, sir.
Sir, it's not audible, sir.
Still not audible. Okay, what I'll do is I'll share this video once we finish this lecture so that everybody can look at it. So what it tried to signifies is, for example, there are parallel runways in Delhi and it handles about 2,000, 2,500 flights every day. But we compare this with a Mumbai is only having a one runway and there is a one cross runway which has been provided for crisscross operations. So now Delhi is having almost, there are 6 or 7 runways which are available and which has been operational day to day. It handles about 2,000, 2,500 flights every day. But in case of Mumbai, since we don't have those parallel runway because of a limitation of land availability, still with the help of intelligent traffic management and transport management system, they are able to operate about 1,000 to 1,200 flight in a day in a 24 hours of time period. So if you do the maths, we can calculate that how much flights it handle every hours or every minute. Now, why they are able to do it is, this is with the help of intelligent traffic management system. So this helps, number one, into the operation of those airplanes which are doing a takeoff or landing. Also, in terms of planning those transportation when a person enters into airport and give their luggage to the check-in counter. Now, how those luggage is been transported from one part, that is check-in counter, to the airport is also very important to know. So the all systems are connected. When a person starts his journey from home and reach to the airport, this all demand catered. So everybody knows where the demand will be in which sector right now and how those sector can be operated with the help of information generated through a different system. So this is marking in a combination and helping them in terms of operation as well as the demand meeting. Somebody saying something?
No, sir.
Okay. I'll just go ahead. So this is actually tells you that the capacity can be enhanced and utilized with the help of a real-time intelligent traffic management system when it is being utilized with the planned services. This is just a pictorial view that how much capacity is there on the highway and how ITS can help them increase. So if an accident or incident happen on the highway, its capacity get reduced to 50% of period. And what 1 minute of delay is actually create a 4.4 to 5 minute of traffic backup, which takes its own time to get cleared. Then if it is a working zone on a highway, it further reduces down the capacity of road. So we have almost eaten up about 60% of the capacity because of incident as well as work zone. Above that, if there are certain environmental condition which are also adding some of the restriction towards the capacity, it further reduces it down to a very few limits. Then special events, disaster activity can also add up to the value of decreasing down the capacity. Now, how ITS helps us? ITS actually reduce down and provide those information which are related to these events to a managed service provider, which can plan those activities and reduce and can increase the capacity to its value, which is required to be done. So in terms of functional area of intelligent transportation system, so we can broadly categorize into 5. One, which can be related to traffic management, is called as Advanced Traffic Management System. Short form is ATMS. So these short form are actually defined based on what functional area it cater to. Similarly, there can be advanced traveler information system, which provides information which are related to travel, whether it is related to a particular bus route or a metro station or reaching to a metro station, for example. All those highway information boards are catered under it. Then there are commercial vehicle operation as well, which also becomes a subset of highway management. Then there is advanced public transportation system, which actually helps in smooth running of traffic and transportation system, basically a public transportation system in a city or a rural area. Then we have advanced vehicle control system, which inside the vehicle helps in control all those systems which are there in the car, in the bus, in the metro. So like that. Now, what is advanced traffic management system? So when we talk about the advanced traffic management system, so this is a combination of various systems which helps and integrate into one control station and helps in decreasing down the dependency on manual human intervention. So there are various systems which are defined under it. It can be a speed violation detection system. It can be a lane management system. It can be a congestion management system. It can be a junction adaptive traffic management system. So there are different components which are mapped under it. And
ಗೊತ್ತಾಯ್ತು ಸರ್ ಅಷ್ಟೇ ಸೌಂಡ್ ಬರ್ತಿರೋದು
okay. So all those systems or different systems, they are clubbed together, they are integrated into one control and command center and help them doing efficient traffic management of various transport and traffic related infrastructure. It can be CCTV based, it can be and LiDAR or radar based, depending upon what technology we are utilizing. We can have this system integrated with each other. This is what overall theme of advanced traffic management system looks like. Moving ahead. So when we talk about, there are different functional area which we talk about in earlier slides as well. So these are subset of it. There can be more system as well, which can be added to it. But this gives you an overall theme that how the functional area of ATMS looks like. So there are red light violation detection system, which what it does is, so it combines the surveillance as well as the backup system in terms of your database related to vehicle, and do a integration and help authority to reduce down the violation on the roads. So for example, there is a particular vehicle which have crossed the red light at a particular instance in a junction in a city. So now what it does is it captures the image of that vehicle which have passed the red light, provide the violators those details, and based on those details, utilizing the system database, that system is actually helps in generating those challans and sent out to the violators, so that next time he should not repeat the same violation again. So this is an example of functional area of advanced traffic management system. Then we have speed violation detection, in which a particular speed of the vehicle is being detected because there are certain limits which is being provided to highways and other roads. So if anybody is violating it, the system helps us capture that and generate the challan against that. Then we have similar to that lane change violation detection system. Then there is an automated accident and incident detection system as well, which helps in providing information to the authority who is working as a management and help them to reduce down the actual impact of that accident and incidents on the road. So we have seen an example that 1 minute of congestion actually adds up 4 or 5 minutes of queue on the road. So this helps in mitigating that, provide a road user at the same time information that there is an accident on maybe 50 kilometer down the line, and there can be another route which can be taken up if it is available. So it helps in both the way. One, the managing the problem which is at a current level, and then also managing the demand which is coming at the same time simultaneously. Then the traveler information system using variable message signs. So those variable message signs can utilize on the roads when it is placed at a right location to mitigate the demand or to tell the users that this is what happening on the road. Then again, the road safety concerns can also be handled through intelligent traffic management system and then incident management as well. So we will give more focus on speed violation and lane change violation system here. So that it should be reflected through the integration of system. So what speed violation detection system is? So there are 3 type of system which is being utilized right now in the market. One which is a radar-based system, which works on basically a frequency. So there is a particular frequency which has been emitted by a device every minute or every second. When those frequency reach to a vehicle present on the particular section, they provides you one, the speed of the vehicle, the classification of the vehicle, and this clubbed with the camera is actually help to check who's the violator and what is the number plate of that violator detected. So one is radar based, which works on the Doppler effect. Second is LiDAR based, which is light detection and emitting. So this actually a camera based solution, which actually emit a light and send to the vehicle so that it when it reflects back, it captures it. So based on that, it detects the speed and it clubs with the surveillance camera and it can detect what is the number plate and what is the time of violation which vehicle have does. Third is the average speed camera evolution. So what it does is, so there are sport speed and average speed. Based on the average speed, it actually detects if the vehicle is omitting that speed limit or was in a speed range which has been provided at a highway or urban road. So this is the 3 system which has been utilized currently in the market. It just in the second line, if you see, it gives you an overview. The camera-based technology will give you a dashboard like this, wherein the vehicle speed get detected. When it detects a particular range which is higher than the vehicle limit which is provided on the road, it actually creates those images. Since chalaning is a subject of traffic police or traffic operator, it actually presents those images towards the to the traffic officer, which has been sitting at the control center. Based on those images and vehicle number, which has been detected by the camera, those violation comes up, number one, and looking at those violation and vehicle number. So you don't have to input anything. You have to just okay if the image is okay. Then it goes to directly to NIC website and challan has been generated for that vehicle. So this is how the overall system works. In terms of architecture, so if you see the architecture talks about both kind of installation. It talks about those speed radar based, which is a portable device which has been used for speed violation detection. It also talks about the fixed radar one that which defines what the fixed installation. So what it does is these on-field devices capture those violation, sent to the switch which is being connected with internet or internet dedicated internet services, and that it dedicated that violation or a video of that particular instance is being sent to the management center. So management center is also having its own software and the AI based video detection system, which does those all calculation and present it on the screen of a system and how it has been connected. So this all is been connected with the network cable to transfer the data from one end to the other end. That's how the overall architecture of speed violation detection system works. There is a small video on it. I'll just play it, which gives you an idea about how speed violation detection system works. It's a radar-based technology which is clubbed with the surveillance cameras. So this is how radar and surveillance-based system is being clubbed. So radar actually detects and give away those frequency emitted every second. And when it strikes with the vehicle, it gives the classification, the speed, and the elevation of vehicle. So these three axes, which actually provides them the elevation and speed of the vehicle as well as the coordinate of the vehicle, so that classification can be done accordingly. Once it has been detected that particular vehicle is going above the speed limit, which has been provided at a certain section, that captured image with the help of surveillance camera is actually being displayed at the screen of traffic officer, and based on that details, he can challan the vehicle at the same time. Okay, the next system is basically a lane change violation detection system. So this system also works on the camera-based technology. How it does it, it create a virtual loop on the road, okay, and it divide into a particular lane system. For example, if you see in this image, here it is been divided into two parts, lane 1 and lane 2. So if a particular vehicle crosses a particular lane and in, then it signifies that vehicle that it have entered from its original position to the next position. And on the dashboard, it identifies that vehicles and gives the color also that what kind of lane change detection is been generated. And based on that lane change, which is been generated through the dashboard, the traffic officer who is sitting on the control and command center can take an appropriate action. So if you see in all these cases, the traffic officer role is very important because as per law, the power is being provided to them. But there are some cases and some example in the country itself wherein the traffic officer involvement is being omitted and the system automatically detects the vehicle, generates the challan and send it to NIC for the challaning. But there are some use cases which needs to be identified for the vehicle. For example, this system overall efficiency reached to a value of 95% and 97%. There can be a case that a vehicle was not exactly a violator. Okay, but his challan is being generated. So all those criticality is being discussed and work is happening day by day based on the AI learnings. But still there is some of the cases which are there are automatic challan generated and sent it to the NIC for challan generation. This is a small video that how the system works. So whenever there is a vehicle which crosses a particular line, the dashboard actually display the vehicle number plate and what are the type of vehicles which have crossed that. So immediately when it crosses, it captures that image and display on the system itself. But again, this vehicle is also not foolproof because there are certain area which can be covered through a one typology of camera. So if you want to have it for each lane of highway, you can have the camera for each lane to make a system foolproof. Right now, if you see, it has been covered with a one camera only, wherein a loop of 2 lane has been created. And if you see, the only category which has been recognized right now is only two-wheelers, not the four-wheeler. So this is the overall understanding of system. Also, I want to briefly cover about the advanced traveler information system, since most of us work towards the highway side of it. So understanding the traveler information system will be of great use right now. So how the advanced traveler information system works is, so there are two subset. One subset which is being used by the operator, the kind of vehicles they are traveling with. And the second subset is the information which is collected through application or web-based services from the users. So what it does is it correlate or integrate both the data set. If you see here, this is the data set which is being generated through the operator, wherein transit data details, real-time information through GPS, uh, transit data which has been enabled in the database, then traffic detectors, the signal, the incident data, that data has been captured from the public sector side or the operator side. And the information which is related to private sector, when somebody is booking at an application, the system will get to know that the person have booked and there is a particular demand on those sector. Okay, so these two data has been clubbed and sent to the server, and data, I will say, data mining. So that data mining helps us to generate those cases, those information which can be utilized to improve this both system. So in terms of details which are related to the users, if there's a particular incident which happened, then displaying the same information on the variable message display boards which are there on the ground, and also to help the operating agency in terms of different information which can help them in decreasing down dependency on manual processes. So that is how the complete traveler information works in a nutshell. I'll just give a pause if anybody have any questions. If not, then we can move further.
नवीन जी, ये कहीं अभी तक इम्प्लीमेंट हुआ है क्या जी, वाहन से इंटीग्रेट करके चालान किए जा रहे हो ऑल ओवर इंडिया कहीं भी?
So it has been integrated for almost every state right now. जितनी भी cities है, smart cities हैं, they have already done it. जितने भी so every city is having a integrated control and command center, and that integrated control and command center is been integrated with Vahan Sarthi and NIC. So they are chalaning the system based on the real-time information which is been provided by those CCTV cameras, surveillance cameras, as well as violation detector cameras. So over 100 cities, I will say, and then few of the highways on which it is been at a implementation stage right now, but few of the highways it has already been implemented. Anybody else, or shall we move ahead? Okay. Just moving ahead. Okay.
Good afternoon, sir.
Yes,
Good
yes,
morning.
please.
You have been telling traveler information system using variable message signs.
Correct.
Can you elaborate it, please?
Okay.
What are
So,
those variable signs and how do we read them?
okay. So let me just take an example. For example, there is a connecting road which is going from Agra to Delhi, and it's an highway. And we have certain, it's an expressway, and we have certain connecting highways with the expressway. Now, what we does is we plan the variable message signs in such a way that it helps a user which is driving the car in meeting if certain kind of incident or certain kind of accidents happen on the carriageway. This is one of the example I'm taking. So for example, at a kilometer stone 50 to 100, there is an accident happen, and that accident management system which is installed on the expressway gives you information about that accident. Okay, and this is a accident which is a life threatening, and there are 4 vehicles which got stuck with each other. So now this information is available with the management, highway management or expressway management authority. So that information can be displayed. So let's say if we need to block that highway section, expressway section, to provide a medical service or provide certain other services to the users at that section, and I have to block it for certain, let's say, half an hour period of time. So if I have a variable message signs which is available at a section where there is a, I'll say another highway connecting to the expressway is available. So I can utilize that VMS to display that information and to tell users that, look, there is an accident happen and for half an hour this expressway will be blocked. So you can utilize this service, take a reroute service, and then you can enter after 15 kilometer of section. So this is just an example to utilize the variable message display boards on expressway or highway. Hope my answer is clear, or any question related to it.
Yeah, clear, sir. Thank you.
Yeah, all right. All right, shall we move ahead? So we talk about the advanced traveler information system. So what are the different, I'll say, functional area of advanced traveler information system? We took an example of variable message signs. There is other mode which is called as highway advisory radio. So to a particular section, we can push certain information which can be utilized with the help of their FM radios, which is running on the car or vehicle. Or we can have speakers also on toll points or different wayside amenities location where those highway advisory information can be played. Then global positioning system, which actually helps in providing certain information which has been collected from the operator and pass it on to the travelers. Geographic information system, then car display screen. So there are right now there are some systems which are running around the world, not in India, I'll say, which displays those information. Even it is there in the private cars also. So when we utilize our map services, there are certain information which is being provided on the display itself. That also helps in getting more information towards the traveler and utilize the same information in better movement and efficient movement on the highways. Then we have best route analysis, which actually Google's provide when we start. We provide information related to our start and end of the trip. It provides you the best route which can be utilized. And we have options of also to categorize the route based on is the toll is being collected on this route or the toll is not being collected on the route. We can have those options selected, which gives us a value in additional value towards our making those trips more advanced, more relaxed. Then the wireless communication, which can also work as a subset to a highway management company. Okay. I guess one of the interesting feature, I guess, when everybody wants to know about is commercial vehicle operations. So it is a subset of what highway management or other management services are doing. So how it helps is basically it gives us a detail which are related to the. So it is basically meant for the agencies which are doing a commercial operations. So for example, there is a one port on which the logistics needs to be planned to a particular various centers. So what control center or the commercial fleet operation center, what will does is it has a information collated through various detector or sensor service which are installed in the vehicle. maybe a GPS, maybe a in-vehicle telematics, which talks about how much tonnage values is there on the vehicle, how much when the gate of that vehicle got open. So all those components is installed on the vehicle. And in terms of fleet or commercial vehicle fleet management service provider, they also have information related to the service completion of that vehicle. So how does it help is it provides all those information to the control center, and they keep that vehicle running for a longer time with the help of these information. So their service has been done on the same or real-time basis. Their information related to what is the maximum permissible limit which is being provided by the authority. Is vehicle omitting that, or is it in permissible limits? That all information also been provided to the users. So indirectly, it is helping those management agencies to do operations smoothly and decrease down those issues which has been created by the commercial vehicles which are plying on the highways. So it becomes a subset, but it is also helping the authority in the smooth management of highway operations as well. This is a kind of functional area wherein the weighing in motion in used, wherein the vehicle weightage is being uh, uh, utilized, vehicle weightage information is being utilized with the help of weighing in motion sensors. So if you see in terms of vehicle category, these are the different information detector services which are being provided on the trucks or different vehicles. Automatic equipment location, automatic equipment identification, onboard computers are there, vehicle system monitors are there, accident avoidance system are there. So it is also been coming in some of the private vehicles now, wherein certain limits can be yeah. I guess there is some question which has been there. I'll just take that question right now. Okay, this has been raised by Mr. Srinivasa. Can we synchronize individual group of vehicle like roadways navigation system to highway monitoring system? Definitely we can do it. We can do it. It depends upon what kind of use case we want to generate. So is those individual or group of vehicles, I'll just give you a small example. So you know that at junction, there is a priority provided to the ambulance services or public transportation. There are certain part of India where it has been implemented. So junction controller is having a particular RFID sensing device. Whenever there is a public transportation in the queue, okay, and if it is on the left hand side of the carriageway, the priority is being provided to that lane to private public transportation to pass on. Similar with the ambulance vehicles. So ambulance vehicles are fitted with a particular kind of RFID tags or the frequency tag. Whenever the controller sense that, it opens it up and provide that priority to the vehicle. So now it depends upon what kind of use case you want to generate. The integration is not an issue. Integration is possible. Whether it is an individual or a group transportation service provided, we can do it. I hope I am able to answer your question, Mr. Srinivas. Okay. Then the vein in motion can also be utilized, wherein this is the main carriageway on the vehicle operation is having, wherein the old category of vehicle are provided. So wherein a particular kind of vehicle crossing a particular limit, permissible limit, which is been provided to the vehicle, because it has been categorized with the help of surveillance camera and the vehicle number plate. And we have database which has been coordinated and integrated with the Vahan or Sarthi, which provide you the actual value of tonnage which a vehicle can take. So once that vehicle pass through a particular component, particular area, there is a violence or there kind of certain issues can be detected. And with the help of toll gate at a particular location, we can have that vehicle checked, wherein it will not create an issue for the main stream of traffic. So this is just an example that how weighing in motion can be utilized in smoothing your highway operations on the roads. Similarly, same can be done for advanced public transportation system as well, wherein those information which is collected from the ground in the form of just like I was talking about the priority of public transportation and junction. So it identifies this is a public transportation system which is coming towards the signal, and it gives those detailing and give a priority to the public transportation system. Similar to that, we can also have similar services done for ambulance, wherein those emergency services has been catered to. Now, when we talk about advanced passenger transportation system, what can be the functional area? One of the functional area we talked about is it can be providing priority at a signal. Similarly, that public transportation information in the form of GPS can be utilized to the display boards. So, for example, there is a bus stop and there is information board which is being provided over there. So those location of the buses can be integrated with the help of control center to those display boards. So if a particular bus at a particular route is located at somewhere, the display board can detect that the arrival time is in 5 minutes. This is the kind of service which can help the stakeholder to utilize those service and cater those demand of that area in a better way. Similarly, this is same again the example where a transponder and antenna is being provided at a traffic signal, which provides priority to the vehicles of public transport. So this actually helps both the way. One, it gives priority to the public transportation system. Second, the users. So currently, why the people don't want to use the public transportation system? So they think that number one, the integration is not there with the public transportation and the travel which they do from their home to a public transportation system. Number one. Number two, they don't get lesser time. Why people utilize metro? Because they get lesser time in traveling from point A to point B. But if same is been does on the road itself as this, provide a priority to the public transportation, it can be utilized and there will be a demand shift from a private mode to the public mode as well. So it helps in direct and indirect ways both. Now next is advanced vehicle control system. So when we talk about advanced vehicle control system, it means providing those sensors or detections within the vehicle itself. So the previously what we were discussing is from the perspective of an highway management company, implementation management company, and from the authority perspective. Now it also provides some of the use case to the users also. For example, here we are talking about intelligent cruise control system. Now, how does an intelligent cruise control system works? Okay, it works on the same mechanics which a speed detection camera was working. So it actually set up a computer system inside the vehicles. So inside the vehicle, there are information provided related to how much distance needs to be maintained with the front vehicle. For example, I have set a value of 100 meter from the front vehicle. So what it try to does is in the cruise control, where I've set a particular limit on which vehicle is running, basically a adaptive mode. In that mode, the vehicle will try to have a distance maintained with the front vehicle. In case if it is 100 meter, it will try to maintain a 100 meter of distance between the vehicle. So what it does is on the backend side is it do a it is a mathematical algorithm which has been fitted in the computer system. When it reaches to a particular value or exceeds, let's say to a value of 70 meter or 50 meter, it automatically apply brakes and reduce down the vehicle speed in a harmonic way, not at a sudden interval. So if you see the use case, it actually helps the vehicle operator to mitigate that accident which will happen if this system was not available on the ground. So with the system, what it does is it applies brake, reduce down the vehicle speed, and accident doesn't happen. Okay, in case the automatic brake has been applied and the control has been taken by the operator. But without system, it go and have that crash happened because there was no system available and the system has been omitted from the integration. This is how that system helps in decreasing down the accident, also helping authority for the smooth operation as well. These are the different, I will say, system which are right now coming in types of vehicle. So starting all again from the safety features of airbag, which get deployed whether you at a particular speed and vehicle hit to another vehicle in front. Similarly, the mirror, seat, sunroof, which decrease down the time spent on different function of the vehicle. There are different transmitter control in terms of cruise, in terms of automatic vehicle transmissions, audio system. There are different ADS, which helps in decreasing down those issues which are there in terms of vehicle. Then if your trunk is open or not, your lights are working or not, how the entry can be made safer to the vehicles. Climate control is there. There are dashboard, there are display boards, which helps actually the driver well informed while he is driving and putting more focus on the steering wheel. So that's how it decreased down those time spent in various functions of the vehicles, which actually help in improving the management of highways and services which is being provided by the agencies. Now, when we talk about the traffic information control for highways, so it is broadly been classified into 5 functionality. One, what kind of system is been composed? What are the information or events I want to collate? So for example, if I want to have very accurate data on the speed, I will try to use radar based or LiDAR based technology. But if I want at a particular section, the speed is to be controlled, I will go for an average speed detection system. So it depends upon what kind of information I want to control, and the system will be based on upon that, whether it is camera, whether it is radar, whether it is light emitting LiDAR based technology. So all those depends upon what kind of information I want to collect. And there are different subset and different solution which are available on various type of technology. Then how I'm collecting the information, whether it is ATCC based, whether it is CCTV based, whether it is in terms of providing those emergency call boxes, those patrol cars on the highway or expressway. Then what are the control measures, control system, which I've been utilizing to control those data which has been collected from the ground? So is my detection information is been connected with the database which has been provided by the government, whether it is integrated with Vahan, Sarthi or NIC to generate the challan based on the information which I've collected. So all those control system which needs to be controlled through an integrated manner. And then what is my field response against particular kind of event? For like for an accident, if I have an SOP defined in the system that the 5 minutes is the golden time, in which 5 minutes on, let's say, and a half an hour is a golden time after the accidents, when the medical needs to be sent to the accident spot. So are my database is being updated with the ambulance service provided in the region? All those contact numbers of those ambulance provider or service provider or medical line service provider are updated in the system. Is my system is able to detect that accident and give me that real-time information or not, so that I can create a field response SOP based on that requirement. So this is how the complete, I will say that traffic information control for highways has been divided into. We will be discussing about each one of these with an example, maybe in the second section of this session. If anybody have any question till now, we can discuss about it, or else we can have a 15 minutes break. No questions? Okay. Neeraj, are you there?
Yes, sir.
So can we have 15 minutes break now?
Yeah, yes, 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 sir.
Okay.
Yes, sir.
Thank you. So any question before we start? Okay. So like we have broadly categorized that what kind of traffic information control for highways can be divided in. So related to system composition, what are the events and information we want to collect, and how we want to collect those information. Then what are the control system we are going to deploy on the ground, and then what are the different SOPs and field response we have been devised using those systems. So I'll just go ahead and there is a video which talks about an expressway or a highway in Rajasthan. So it talks about how those accidents are happening, whether if those information is been collated on the ground, that those accidents can be mitigated. This is a small video on it. This was on expressway. You can see the situation on the ground without having a prior information of what is happening in front of you. See, nobody is having information that there is an accident happened in front, and it was a fog. The day was completely foggy, so there was no visibility or limited visibility on the expressway. You can see the situation. So this can be mitigated. I will not say that this can completely be ignored, but this can be mitigated if we have a certain intelligent traffic management system or real-time information system which are installed on the ground and can tell us about how this is happening. I'll just take a particular example which happened in real case with me. So I tend to have a like understanding, or when I start driving, I put those locations where I want to go in the Google map. This was a particular case and similar to this happened with me. So I was moving on an expressway, Yamuna Expressway from Delhi to Agra. And I was utilizing Google services to have awareness about what is happening in my surrounding. So what happened is at a particular instant, what I've seen is there was a particular red spot which is in middle of nowhere on an expressway. So I was very curious about why it is happening. What was the reason of having this red spot or a congestion point in middle of expressway when there was no tollway or no ancillary services is being provided by a management company or whoever is operating those expressway. So I was curious, so that my speed was very low as compared to the other vehicles which were plying on the express highway on that particular day. So what I've noticed is this particular red spot point was an accident spot, wherein all those vehicles were entering and colliding with each other because of no information has been provided to those traffic players, or they didn't have or little information that there is an accident happen and this is what is happening in front of them. That's how the knowledge or information can help mitigate those issues or those safety concerns which are led in case of known presence of those ITS systems. This is few of the example. If you see, this is an expressway from Noida to Greater Noida, and you can see there are two-wheelers. There are, I'll say, those Grameen services which are being flying from those villages to the cities. And there is vehicles stop by on the expressway and right on the carriageway. So all those things, if certain services, certain information system are available on the highway or expressway, the management service provider or highway management service provider can mitigate those and take a particular action to mitigate that. Instead of so what is happening right now is we don't have those means from where the services or the information can be collected on the highway or expressway. Though with changing practice and changing working condition, we are making it a mandate while we are starting construction of those highway itself, which is a good step in a better managed environment. So when we talk about what should be a system composition, the system composition depends upon what kind of incident is happening, what kind of information we want to collect, and what are the control measures which will be directed from a control station, and then how those information which is being collected from incident and information collection is been disseminated to the users. So this becomes an overall system composition or system architecture for any intelligent traffic management system which we want to deploy on the ground. Now, these are the various essential component of a traffic information control system. So it will essentially have those applications which help in integrating of all those devices which are there on the ground, and all those control devices which needs to be react when a particular kind of incident is being triggered. So in terms of applications of software, there should be a traffic enforcement system. There should be a management software which helps you in planning, management, and operation of those asset or transport infrastructure which has been utilized by you. Then the surveillance, the know-how of those infrastructure is very important, and how those response is been designed with the help of emergency and incident management application. Then the dissemination of information through traveler information and interfaces with various other transportation system which are running, alternate mode of transportation which are running, whether it is related to transit system, whether it is related to incident and emergency management system, road accident. So all those information needs to be priorly fed into the system. Then the backend standard software is being provided with each in every system. So what the operating system to prevent any intrusion or any issues with the system, all those backend standard software needs to be have in the system. So antivirus and database, all these details need to have. Then there should be a center hardware to overview all those system, how they are working in terms of video walls, which provide a visibility to the operating agency or the operators which are sitting on the control center, computer operators, storage area networks, network and communication between different router and switches on the ground, and printers. Then the field equipment, which are related to detection of those incidents and issues which are there on the ground. Surveillance equipment, variable message signs to convey these messages, and communication equipment. And then various utility which helps control center to work 24/7 in terms of fire suppression, air conditioning, access control, power backup, etc. Now, the previously which we talk about is the essential component of any traffic information control station. Now we talk about the optional component. It depends upon the kind of services you are providing. All those services needs to be integrated with integrated command and control center or traffic information center, control center. So it can be if you are doing a use cases related to parking, safety, toll operation, congestion pricing, integrated control, light control, weather control, then you should have modules of each interface in your system. If it is not, then these modules are optional. Then field equipment related to those application software which are being procured additionally, and then facility to have those operators can run those operations smoothly. This is a particular example of what are the different timelines and what are different processes which procurement, as a procurement manager, you have to go through, and what are the different timelines being covered under it. So it essentially starts from starting your concept development phase, wherein we identified the need and what kind of solution we required for highway management or an urban road management. Then based on that, we prepare a high-level architecture wherein we say we require a parking management system. For have a parking management system, we require this detection based on maybe neural network, maybe magnetic field devices, maybe a camera-based solution. So camera will be required as a detection point. Then the connectivity, network connectivity from the detection point to the control center, so that those information can be collected from detection to control center, and thus processing of data can be done at control center. And then finally, how that information will be utilized for betterment and efficiency of transportation infrastructure. So the functional requirement, high design, testing, verification. So this particularly takes about 2 to 4 months, which also include detailed design, site designing, and hardware component driving for traffic information control center. Then the detailed project report takes about 2 to 4 months. And after we do the detailed project report RFE, it takes about a particular 2 months of time period, bid process management, and then the implementation depending upon the area of solution to be deployed. It takes about 6 to 12 months for the solution testing, deployment, and user acceptance to start running a system. So we should plan in such a way that it generally adhere to whatever is our project timeline, right? So this time can be reduced or increased based on what are the different area we are covering, what are the different solution we are deploying simultaneously. Now, the overall system composition, if we want to look upon, so these are the detection points from where the information is being getting collected. So here you see there are different solutions which is being provided. One is weather monitoring station, which is providing information related to environment management, or what kind of temperature, what kind of rainfall it is being observed around the influence area. Then those information based on certain collection devices like vehicle detection units, emergency telephone, ECBs, those information is been collected and passed it on to the control center. That control center process the data with the help of application, with the help of on-premise or cloud-based solution, which has been provisioned in the system. And based on that processing of data, the information is being passed on to the various devices, various information dissemination devices across the utilization of your system. So this is how the complete system is being drawn. Similarly, this is for the complete high-level architecture, which talks about the field equipment, the real-time data collection, which is happening through these field devices. And that information is being processed through database and application and servers. And that information is passed through the traveler for better utilization and efficiency of transportation system. So
वाली आई हुई है, फाइल में लगा देना.
Okay. So here I want to talk about a particular example that what kind of event I want to cover, and is that event is an active or needs to be linked with the active warning system or a passive warning system. So here in this case, we are talking about the active warning system when we are collecting the event and information. So active warning system basically an adaptive system in which the any kind of information can be displayed. For example, when you talk about static hazard with a uniform relevancy, so there may or may not be required a particular adaptive system in which any information which needs to be displayed, it only relates to a particular instance. For example, static hazardous and uniform relevancy can be of warning sign of sharp curves or lane drops, etc. So this is a particular kind of instance and can be done with the help of static message information provider system. Then there is variable hazard, wherein there are different information which needs to be clubbed in a particular system, which can be related to changing weather condition, temperature, the pedestrian warning, and animal crossing warning signs. So those can be a variable kind of hazardous, which with known and with uniform and non-uniform relevancy. And then it can be a clubbed one, wherein the static hazard and variable hazard both can clubbed with a known and uniform relevancy. For example, there is a certain change in the grade of a particular highway. There is certain change in profile of an highway. There is a particular clearance warning which needs to be provided for larger vehicles which are crossing through the bridge. So your event and information should be defined based on what information I want to collect from the ground. Or is it a uniform one or a non-uniform one or a static or a variable one? This gives you some of the example wherein active speed warning signs are being utilized, wherein these are not fixed on the ground. They can be changed based on the requirement of authority. But it doesn't mean that static or the variable have a different relevancy. If we see with an example of active speed warning signs, it was found that in most of the cases, the 85th percentile speed fell by 27% after installation. So this is not only the violation chalani, violation detection itself helps in decreasing down those probable issues which will be caused unless those information system are being deployed on the ground. So this is also becomes a very beautiful example and helps the authority in decreasing down those violations if we don't have those integration with Chalan system also. There is another system which is an adaptive queue warning system. So this is related to a construction zone wherein there is a some construction zone which has been created with an created on the highway, and now we wanted to have an adaptive queuing warning system which helps in better management of my queue on the highway. So in this case, what I does is I divide section of the road wherein construction happening or some hazardous activities are happening into certain sections wherein I imply or put certain beacons which help me to detect the speed of the vehicle and then particularly decreasing down those vehicle speed with the help of certain signs which is being provided on the ground. So if you see in this case, it has been divided into 3 sections with 12 to 1500 feet each. And there are particular speed limits which has been derived on this system. So it is asking vehicle to harmonize its speed limit. And when those display has been provided that it is a construction zone and the lane is getting skewed at a particular section, the vehicle itself manages to maintain and manage the queues inside those sections. This is a example wherein those construction zone can be handled very aggressively and decrease down those congestion times. So we said in the starting that 1 minute of congestion is added to about 4 to 5 minutes of clearance time. So this helps in decreasing down that clearance time and help better managing those queues which is being built up because of any event or accident which happened on the ground. Okay, this is again those beacon, how they can be utilized, how those upstream and downstream sensor can be detected with the help of beacon. So all those things can be managed through this particular example, wherein those sample data and signaling data can be mixed with the database which are there in the control center, and that can be utilized with the help of those detection system which is there on the ground. And with the help of that detection system, that event or that particular case can be managed. Now, next is the variable speed limit for speed harmonization. So similarly, what we did in last case is a queue management system, wherein we were managing the queues and making those variable advisory details which are coming through the queue, and managing those queue which were happening on a particular highway. Now here, the details which are related to is the speed harmonization. So you want to have a variable speed limits at a particular location. So depending upon that, those messages will be displayed on the VMS, and those variable speed limits will help the users to maintain those particular kind of speed at a particular section on highway or urban roads. So this is how it has been done. So if you see this board, there are 3 different lanes which has been there on the highway, and those 3 different lanes are maintained with a particular speed, which helps authority in maintaining a different speed in a particular lanes. So if you see on your right hand side, there is a particular rest area which is being provided. So if we don't keep this speed limits at a particular lesser or equal to that value of what is been implying on different section, there is a chances of accident happening on this section. So that's how this speed harmonization actually helps on ground staff or management company to decrease down the speed or particular case wherein speed harmonization is required. Now these are the different information collection devices from which I can or based on the requirement of system, I can collate the information. So I guess we haven't talked about the emergency call boxes. So these emergency call boxes is provided along the highway for the requirement of any emergency conditions. And what it does is whenever a button is being pressed on the emergency call boxes, a particular ID is assigned with a particular emergency call box. So that ID actually provides the location of that users on the ground to the control center. So with that particular ID pops on the control center, and with the help of pressing that button, the users can talk to the control center, and particular kind of help can be asked from the users. That is the one example of emergency call boxes. That's how it needs to be done. Second is radio mobile communication system, which generally can have connection with different operator, which are as a ground staff monitoring and managing the highway. So those radio mobile communication system can be used by them for efficient operation of those highway or expressway where they are working. Fiber optics communication system. So this is a connection or network connection which is being provided with the different direction device and a control station, so that effective information can be passed on between the 2 detections and user department. Then CCTV monitoring system. So this can be utilized again to collect particular kind of instance, whether it is accidents related or event related, or if we want to clubbed those information with CCTV and a particular system like radar based or LiDAR based system. So that integration can be taken place with the help of CCTV monitoring system if it's installed on the highway or expressway or urban road. Variable message signs to collect. So we can have variable message signs fitted with environment sensor, where those information related to weather or particular kind of CO, NO or PM 2.5 values needs to be collated. Those variable message signs itself can have those sensors, and those collected information can be displayed to the variable message signs. Then some meteorological data, if it is available in the database, or it is been pushed from department to the system, so that information can be collected and utilized based on the requirement. Then we can have better planning and management, both with the help of automatic traffic counter and classifier, which gives you an actual value. Day to day, my capacity is what and how it is being utilized by the users. Then the video surveillance system, video incident detection system, control station. So all what we keep it as a contract value on all these system is it should be available with 99% of the time. And in case of any
Naveen ji, you are not audible.
Sir, yes, sir.
okay, great. Probably some network issue at my end. Okay, then we are talking collection devices. So these are few of the example how the incident detection using camera can help in mitigating and more utilization of highways. So with the camera, there are certain rules or regulation which can be created using the algorithm, mathematical algorithm. Without those algorithm, the camera's feeds are being processed in the video management software, which helps in detecting of particular incident or accident if happened at a particular level. So how the algorithm is being configured is if a particular vehicle is standing at a particular point for a longer than prescribed limit, let's say 15 seconds, 20 seconds, 30 seconds. So there is some issue which is related to it. That is how the algorithm is detected. So it takes the images of those incident point and pop up on the system for the better utilization of control authority to see what is happening in that case. So that is one of the example how the detection is happening. And based on that data or that visual image which has been collected on the control center, the quick emergency response team can be configured so that they can reach to the spot and provide a particular emergency service which has been required by the users. VMS we have already discussed about. There can be a different type of variable message displays which displays about the information which are related to a particular sport or particular location or particular diversion if it is some incident have happened. So that information can be provided with the help of variable message signs on the ground. Emergency call boxes we have already talked about. So it generally been installed at a uniform distance on the highways. It provides an accessibility to the users so that he can press the button and contact the control center in case of any emergency. So the audio is being processed. So it can have both kind of services. One can be an adaptive phone calling, wherein based on his voice, a particular options will be provided to the users, or it can be an adaptive one as well, wherein the user will take the phone and try to understand what is the issue and concern on the ground, so that he can send a particular kind of support which is required on the ground. Then mobile radio devices, which can be utilized by patrolling vehicles, cranes, or ambulance, which are there on the ground, and act as a supporting services in case of event or accident management happen on the highway or urban roads. CCTV surveillance, we already talked about, and how we want to utilize those CCTV surveillance. It depends upon the kind of system we want to deploy on the ground. I guess this one is detailed out. So this is called as adverse visibility information system. Now this has been detailed out. How it has been configured is very important to understand. So there are these all sensors which are deployed on the ground, which are collating all the information throughout 24/7 interval and passing on that information to the control station. And we have a dissemination devices in terms of variable message signs, which are displaying those messages which are there on the ground. So how it does is, this information is being passed on every minute to the ground station, and that ground station collate that information, process that information, and what information needs to be provided to the users is being provided to the VMS. On the back end, in this station, there is a different operating system which are being provided, which are processing a particular data. So these are related to fog, these are related to loop, which are there on the ground to counter traffic. So all those information is being collected, and based on that information collector, there are active and inactive information provider is being provided. One, there is VMS. Second, there is a loop detector, which actually controls the speed and the classification of vehicle which needs to be run in a particular lane. Now, how the system is been designed is needs to understand. So there is a particular SOP which has been defined for the visibility condition in the system itself. So if the visibility condition is 700 to 900 meter, then this is the control strategy which implies in the system and which been provided on the variable message signs or data acquisition system. Then if it is 450 to 700 meter, then a particular case of reducing the speed and switching on the DMS lights is being provided. Then 3 to 450 meter, the DMS should be on and it should be reduced. The speed again should be reduced to a particular speed limit. Same if it is less than 300 feet, then pavement lights get illuminated, overhead street light starts, dense fog reduce speed limit to 25, and trucks keep on right. So all these SOPs needs to be defined in the system before getting deployed on the ground so that the efficiency can be increased. So this is how the warning system component was designed and what it includes of. So it includes of scatter visibility sensor, which provides you the visibility about how much visibility is there in this on the ground, so that it can link with the system. Then the pavement light installed at 100 feet spacing, so that it gives you a visibility that there is something happening and you should decrease down the speed of the vehicle. Then there is adjustable street light controls. There are CCTV cameras. There are enlightened DMS, which is being provided on the pavement itself, which get illuminated with the help of control, which is done at the control center. Then remote processing unit, control center, and fiber optic cable to communicate with each of the system which is deployed on the ground and the control station. So this is how the systems helps in decreasing down the particular kind of incident we have seen on the expressway, which was happening on the video. This is just an example of it. Then we have electronic toll collection also, which is like when we see what was there before the electronic toll collection came into actual picture, we actually chosen the FASTag as a system. So the challenges were there was no unified technology. So one highways, one expressway was working on a different set of technology, and another was working on a different set of technology. So sorry. Also, there was lack of understanding amongst the manager who were managing the highways and expressway about the ETC technology, that how it works, how it helps in getting the exact value for a highway management and decreasing, and therefore making the project more sustainable in compared to the other projects which are done from the government funding. And then there is a legal provision also was not there in the contract for ETC interoperability between the different highways and expressways. So we tried to have a particular kind of system in which we have chosen the FASTag as a technology. It's a EPC Gen 2 RFID tag, which actually provide information related to the vehicle, which has been tagged to. And then it also relates to a particular kind of fees which needs to be deducted when kind of vehicle which is identified with a particular service is passing through a particular toll gate. So all those things needs to be related and integrated when we are using the FASTag services. So this is how it works. So it's a radio frequency identification tag which have an antenna and chip which provides you. So there are two kind of setup. One is RFID tag, which is a transponder. Basically, when it comes to in contact with the RFID reader, it provides a particular ID and details related to a vehicle which is plying on that toll point or a highway. Then a host terminal or information database which is being provided to a details related to host terminal, highway, middleware, computer and software details. Then those FASTag related data is been read by a FASTag leader, which information is passed to a host terminal controller, which actually lifts the toll gate to pass a vehicle from a particular instance. And on the backend side, it is been linked with a payment system. So a particular kind of toll plaza having a particular ID related to FASTag ID, which has been collated from the vehicle player. That information is being passed to the acquirer, and then acquirer contacts with the NETC, which is a online switch and mapper, which provides you information related to the bank or particular kind of payment detail related to the issuer, and that payment get deducted when a vehicle passes through a toll point. So I guess this is very known to each and everyone, and there's no point discussing about. And that physical barrier has been replaced with the help of a foolproof system, which captures the detailing of vehicles and collate and take out that payment which is required to be deducted from a particular users who is flying on the road. I'll just stop here and see if you have any question which are related to this section. Any particular question, if anybody has, can be taken up here. No questions? Let me see if any question is there in the chat box. Shall we go ahead? Neeraj, are you there?
Yes, please.
Yes, sir.
Sure. Okay. So till now, I guess we have talked about only the information which is getting collected from the detector and sensor. Let's talk about now is a traffic control system. So, the traffic control system also depends upon your requirement. For example, let's talk about speed management system. So because it's acting on the way, noting down and taking out the speed of the vehicle which are flying on the road. Okay, and then managing that speed so that the vehicle should not enter into a fatal accident because of that speed which is he running. So this acts as a kind of control system. So how it helps, so control system, what we require is different kind of system is. So in terms of speed, if you say there are different systems which are available on the ground. It can be in the form of inductive loop sensor, video camera, which helps with the still or flashlights we discussed about earlier as well. And then controller equipment to communicate with the system. And then kind of sensor which actually notes down your speed from the ground. So again, the system is similar, that it collects various information which are related to vehicle speed, pass it on to the control station. Then control station is having a database which tells them that this particular speeds is and that information has been collated from the data which has been present in the database. So that particular section has been provided a particular speed limit, and that information has been related to a section, and that provides if that speed limit is above or below the certain speed limits which has been provided at the section. The same method is being utilized here as well for detailing of it. Then there is an example of case studies. So one is Yamuna Expressway. This is completely an RFID based electronic toll collection lanes, which is provided on the toll plaza at Yamuna Expressway. There are various variable message signboards which has been provided on various location depending upon their requirement. And there are surveillance camera to look at the highway at every 5 kilometer and video incident detection system at particular details, particular interval of time, which has been collected in the system. Then there are speed monitoring and vehicle recognition system, which has been deployed on the expressway. There is a central control command and control center, which is collecting all those information. Emergency call boxes at every 2 kilometers is also been provided to have a particular instance controlled when there is a need of help required on the ground. This is another case study of Shin-Tomai Expressway in Japan, which is related to next generation traffic control system. So they have various centers which has been deployed. One was deployed in the Tokyo, another was deployed at the Hichoi's branch. So all those systems at a particular, so how it has been working is, so there is an integrated control and command center, which has been working as a controlling of each station, which is provided with those sensors and controls. The data is being sent with the help of this control session to the integrated control and command center. And that integrated control and command center actually helps in managing the traffic. So this is like there are 10 highways which are lying in different cities or different districts, and those highways are being provided with the control center, and there is a above control station which is working at a particular district which is controlling all these highway management information. This is another example. So they have data collection devices which is installed on the highways, which is passed to the control center, and control center helps in dissemination of information in a better managing the highway. This is another one which has been provided in UK. So this is called as the National Traffic Control Center, and this actually helps in collating the information from 4,000 strategic monitoring sites across the country. And there are different core routes and feeds which has been provided to NTCC, wherein those information is being collected, and management of those highways and expressways which is across the country has been done through this control station. So it works on the same methodology. It collate information which are related to various vehicles which are plying on the road. It collate those information and provide in terms of information dissemination to variable message signs, telephones, or internet, which are helpful for the users or public who is plying on the road. Then it also disseminate information to the media, radio, or TV channels, so that those information can also be reached to the people who are the potential user in coming days. And also this information is being utilized by the service provider, which are there who is operating their commercial trucks or buses on those highways. This is another example which is related to bus rapid transit system in Ahmedabad, which is one of its pioneer BRTS system running in India. This has been installed with fare collection gates, passenger information system on the station, means the bus stops, as well as inside the bus in terms of passenger information boards and details. Then another example is intelligent transportation system in Mysore. This was the first intelligent traffic management system which has been deployed in India. This was started in the year 2012, wherein KSRTC, Karnataka State Road Transport Corporation, wanted to have integrated and intelligent transportation system for their JN and URM funded buses, which is being given by the urban development government of Karnataka and KSRTC to them. So what they did is they have installed the passenger information system, PIS display boards on the bus stops. They have the in-bus display systems on inside the bus for better informed users, and the control station which is actually integrating and collating all those information and passing on to the users. So what type of real-time passenger information they were providing in their system is, so in-vehicle display and automated voice announcement system has been provided in the buses. There were central control station which were helping them integration of detection and dissemination. There were automatic vehicle location system which has been provided, which actually helping the display boards to getting those relevant information related to bus location. Then enterprise management system for their users and the employee which were there on the routes, so that the scheduling of them can be done with the operating system and those related software of it. Then these are all connected through a network. So network management system is also being provided, which help the system running 24/7. There can be generated from the system. There were PIS boards at bus terminals. This is the overall dashboard which has been developed for the users, which gives information related to your bus, where your bus is, what are the different timetables, what are the different route details, Any information which is related to bus fare or the system which has been deployed on the ground has been provided through a commuter portal. Then GIS base map is also been developed for the city, which actually provides information related to the bus location or positioning, which can be utilized for better operation of bus system. These are the various advantages which came out from this project, and that's why it has been utilized nowadays with every transportation system or every transport department of state. The real-time information for passenger about bus arrival and departure has been provided, reduction in waiting time, increase in demand in the public transportation. So people were more informed about bus services. So that's why they were using very often, because they were on time and they were actually reflecting the real-time information to the users. This also helps indirectly in reduction in traffic congestion, improvement in efficiency of traffic operations throughout the city. Congestion level is decreased, then ultimately it helps in better environment quality, reduction in fuel consumptions, which are being utilized by the bus transport, and then improvement in economic activities of the services. This is again one of the first project which is taken up in India, which was B-Track. This was by Traffic Police of Bangalore. This initiative was taken in 2010, and focus was on installing those intelligent traffic management ITS devices, doing a digital surveillance of junctions, street furniture. There were various enforcement cameras was also installed. Then there is a traffic management center which has been built, which is controlling all those detection devices on the ground, which are there at junctions, at the various corridors. Then online information from cameras is been collated and controlled in the management center. Better compliance of laws and reduce accidents was one of the benefits from this system, and traffic training and road safety institutes also being planned based on this to decrease down the road accidents and capacity building of the department. They have also developed an application app, which actually helping them in one-point integration and one-point information for various kind of transportation system. So it provides a single source, all public and private mobility options to a users through a mobile application. Unified account was created, payment was also being deducted through the application, and various rerouting or dynamic rerouting options were also provided to users. So this is how, this is an example that in case those integrated services is not being provided, then how the system will work. And in case those services is being provided, then how that system can be utilized better. So if you see my example from A to B, so right now there are a lot of trips which are happening through the car. So instead of a private air cab or a public transportation system which can be planned on this route, now this route will also be having those last mile connectivity trip which is coming from home to a particular station. So that trip is also being can also be planned and mitigated with the help of providing an bike sharing scheme to a particular area A or B. Okay, and then those services which are related to catered by a private mode right now can be catered through a public transportation system. So if we have those real-time automated decision maker support unit provided to a decision maker, then we can very well take this example and have these services planned in such a way that it should complement each other instead of compete. So that is another benefit which intelligent traffic management system can provide to the operator as well as users. That's it in terms of content from my end. Any question, any points we want to discuss now? The floor is open for everyone. Any real-time issues which you are facing in your project, or any of your project which are can be deliberated here, can be discussed upon.
Now the participants are requested, please ask their questions if they have any.
Okay, let me start with an example. I'll take an example of, let's say, Maharashtra. So there was a city called Nagpur. Okay, so Nagpur is already having intelligent traffic management system, which is currently being deployed by the smart city of Nagpur. So what this system is helping is better management of traffic condition in the city. So now what they were doing is they were having those enforcement camera which were detecting the violation on the junction and different corridor of the city. So they were collecting or collating information related to violation. Those violations were then being sent to NIC or linked with Sarthi and Vahan to get the challan generated. Now, what happened is, and this has been phased in all around the country. So what is happening is they are generating the challan. The challan is being sent to the users, but what it is being observed by Nagpur Municipal Corporation or Nagpur Smart City Limited or Maharashtra as a whole, the number of challan which is being generated is, let's say, equal to 35 crore of value. But how much they are getting collected is equal to a value of 7 crore. So you can understand that in terms of violation, they are generating challan of equal to 35 crore, but what they are able to get it from the violators is only equal to 10 or 20% of that value. Now, this question was deliberated among all the user departments, whether it is transport, whether it is state PWDs. So although, because this actually, this challan which is getting generated from those systems is actually helping to have more better infrastructure for the cities. But those values has been not been generated through this processes. So now after this discussion and their discussion with all over in the country with different states, so they come out with a policy. So which will be implemented maybe in the next 1 or 2 years of time period. So for example, if a challan is being generated for a particular violator and he is not paying that challan, so at a particular instant of time it goes to a court, and there is a particular case is being drawn to a particular violator. So this challans and these cases were pending in courts and they were not able to dispose of. So now what they are doing is they are creating a policy with the help of IRDA. So now if you have a challan and in next 2 or 3 years you are getting your policy or insurance renewed, so that challan will be shown in that policy. Unless you pay that challan, you cannot have your policy renewed. So this is one of the combination wherein with the help of technology, we are able to generate more challan and to catch more violators. But at the same time, with the help of policy, we are mitigating and increasing the inflow of value through challan for more comprehensive, improved infrastructure for the cities. This is one of the examples. Anybody want to open up, share his experience?
What if the address mentioned on the registration plate and the mobile number registered with the RTO are not updated? Then in that case, and
that's
then
a relevant question. That's a
then in
relevant
that
question.
then in that case, how the recovery against the challan can be made? Can you explain
Okay.
it?
Yes. So these are the cases we see day-to-day basis in the cities where these solutions are deployed. There are a lot of cases wherein the message and email is been not been received by a user who's a violator. So what is a solution of those cases? So what is happening is, so there is a particular registration number which is involved with the address. So there are 2 or 3 iterations which the authority is doing. One, they wait for that challan to be paid by users. If it is not been paid in a particular interval of time, then it goes to court. Okay. Now, what they are doing in between is, in this time period, one, they have the term called as recovery managers. So they have call center, what they are doing in Maharashtra right now. I'm quoting an example. So they have this recovery manager, which are being positioned at various locations in the state with a control center and phone in their control. So if the user is having correct email ID, they try to push the users to pay their violation challan. If at all they find that a particular case wherein those contact numbers and email ID is not reachable, they try to have those address covered through one of their users, because that is the only thing which you can do if you don't have those user mobile ID, mobile number and email ID updated. But now it has been smooth from last 2 or 3 days. It has been mandatory to have a contact number and email ID for any registration which you are doing in any of the RTO in India. So that's how they are mitigating it, not only by an active mean, by a passive means wherein their recovery managers are actually being sent on their houses, their addresses, where the vehicle is get registered to get the information related to the violator. Anybody else? Any question?
One more question.
Yeah, please, go ahead.
If there is a vehicle listed in the name of X person,
Mhm.
but Y person borrowed that vehicle and violated some rules, then the challan goes to the X user whose vehicle is been registered in the name of so and so person. If it is violated by the Y person, then the challan should be to be deposited by the Y person. Somehow it may not be the Y person deviates from that. I have not rode that vehicle and I have not violated any norms. Then in that case, how the enforcement will be done?
Okay.
If it is not controlled by the ANPR cameras.
No, I understood it. So you are saying there is X system जो हमने deploy किया ground के ऊपर. For example, let's say I have the speed violation detection system on the ground. Now the user is committing a violation which is not a speed violation, is actually maybe a triple riding, maybe a no helmet. Correct?
Okay, right.
Okay. So you are saying if the person have omitted any other violator and I am challaning him for speed violation, that is not correct.
No. Not
Okay.
in a different section. I'm just saying Y person took the vehicle of X and he committed the crime or violated the norms. Then in that case, how the challan will be recovered from the Y person, not from the X.
I understand. So here what you are saying is, let's say there is a vehicle which is of a different owner and is been ridden by different users.
Yes.
So you are saying not challaning the owner, challan the rider. Okay. So see, Anuj, so we set certain ground rules when we drive some system. Okay. In this case, the system is been designed based on that vehicle plate, vehicle number plate. Now, if you change your system to a user face recognition, right? Instead of vehicle plate number, now you are recognizing a particular user who is driving the vehicle. So if your authority says the challan should be done for a rider, not the vehicle, then you can have that solution developed. The solution is available in the market. So there are surveillance camera, good surveillance camera, which actually recognize the face of the person and match with the database. So once the database is been matched and the ID is been discovered of a users, then you can very well challan that user also instead of vehicle.
Okay.
So it totally depends upon what you require and how you want to configure that solution. So any kind of solution is available right now. There are solutions which recognize face also. It also recognize the body type also.
That's it.
So that is, I guess, answer of your question.
Yes. Thank you, Naveen ji.
Sure. Anybody else?
If any participant want to raise their question, please ask your questions. Otherwise, we may conclude today's session. It is again requested to the participant. If they have any questions, please ask your questions.
In case anybody wants to write to me about there any problem, any issues, they can do write on the email ID, which is provided on the screen. I'm just putting it on the chat box also for your use. And I'll share this presentation with Sir so that it can be circulated among each participant.
Naviji, I think that there is no more questions from the participant side. So now, at this moment, we will conclude this session. Sir, thank you very much for sharing the presentation as well as sharing the experience. I think that the participant will get the benefited from your lecture. So now from these words, we conclude for today's session. All the participants are requested to join tomorrow at 9:45 a.m. So thank you very much to all the
Thank you,
participants.
sir.
Thank you.
So much.
Thank you, sir. Thank you. Very good.
Okay.
Thank you.
Okay. Neeraj ji, now please finish the meeting now.
Yes, sir.